I would like to give a brief idea what we are going to learn through this session. Especially, we will divide this training into two. One is Hypermesh training, okay? Then Abaqus, right? So initially, we will start with Hypermesh. Then we will jump into Abaqus, okay? So what are the things that we will learn in Hypermesh? Especially, we will learn the meshing. Okay. In meshing, we'll initially learn BAW meshing. Okay, BAW meshing. This is called as body in white. Body in white, which means this will be having a uniform thickness. Okay, so whatever the components that you see in an automobile which is like painted, that we can categorize into this one, BAW, right? Then second thing is plastics. This will be having variable thickness. Okay, variable thickness. So for this one, we need to extract the middle surface, and onto the middle surface, we need to mesh. Okay. Then third one is 3D mesh. Okay. In 3D mesh, first thing we will learn like tetrahedral mesh. Okay. Then second thing we will learn like hex mesh. So in terms of the meshing, these are the things that we are going to learn. So if I am giving an example for this one, like so whatever the uniform thickness components like fender. So what is fender, what is dashboard, everything I will just show you in the upcoming training sessions. Fender, then bonnet, sunroof, tailgate, etc. So plastics means infotainment. You might be knowing. I mean the dashboard and the rest, etc. Okay. In the tetrahedral meshing, like especially it's coming under the suppose all the casting components we can say like coming under this type of machine. Okay. Say engine block, connecting rod, piston, etc. So in X mesh, we can say like some kind of clampings, universal joint, etc. So all these machines, type of machines we will be learning. So prior, we need to learn some commands in Hypermesh. Okay. So if I would say the Hypermesh, so Hypermesh actually it is a pre-processing software. Okay, pre-processing software. So in every analysis, it includes we can say like 3 stages. Okay. One is pre-processing. Then solving, then post-processing, right? So in pre-processing stage, we have to do certain deck setup, meshing activities and all. So for that thing, we are using Hypermesh here, right? Actually, there are some other softwares as well for the pre-processing, but predominantly industries are using Hypermesh and ANSA, and some companies are using Meshworks. Meshworks. Okay, so these are the two two softwares which are used by industries for the pre-processing. Okay, so Hypermesh is a pre-processing software which is actually developed by Altair. Altair is a software company who developed the Hypermesh software. Okay, so ANSA, mainly the, I mean, European countries based industries will use ANSA, right? So in these training sessions, we will focus on the Hypermesh software, right? So in the analysis stage, for the pre-processing, we'll be using Hypermesh, right? And for the solving purpose, actually, in industries, there are several solvers, okay? Say Abaqus, and we can say LS Dyna, okay? Nastran, Patron, ANSYS, radios, etc. Okay, there are several solvers, right? So LS Dyna, mainly they will be, it is, I mean, robust in terms of the explicit simulations. So Abaqus, Nastran, Patron, ANSYS, radios, etc., etc. So we'll be focusing mainly for the Abaqus solver. Is a very good solver which is having the capability to solve all the implicit and explicit simulations, right? Then coming to the third session, that is post processing part. Here also we are having multiple softwares used. So in our training we will be using Hyperview. Okay, Hyperview. Hyperview, again, it is a, I mean, product from Altair. Okay. Then some companies use Metapost or Abaqus Viewer. Abaqus Viewer, right? So we'll be focusing on the Hyperview when we coming to the post-processing stage. So this is all about the, I mean, analysis, just introduction, right? Then so once again, in Hypermesh, so we will just jump into some very few basic things related to FEA. We are not going to dig much into it, but just to revise the things. Then we will just directly go to the Hypermesh interface. Then I will just explain a few commands. Okay. And one thing I just want to say here, the Hypermesh software actually having 24 commands. Okay, 24 commands, which we can categorize into two groups, 12 plus 12. Actually, some commands are similar, but collectively we can say like there are 24 commands in Hypermesh. Okay, so what are those commands? One is F1, I mean the button F1 from F1 to F12 is one set of commands. Okay, this is one set. Then second set is this first set, and the second set is shift plus F1 to shift plus F2. F12 is another set of commands. So I hope it makes sense. In Hypermesh software, there are like two sets of commands, total 24 commands, in which one set consisting of from F1 to F12, and the second set is like shift plus F1 to shift plus F12 in that way. So we will just we'll explain in detail all the commands in the later sessions, and once I just start explaining the commands, you will get better insight on the same, right? Okay, then we'll just have some basic idea. So as we know, like Hypermesh is a software for the pre-processing stage, right? So why we need meshing? Why we do carry out meshing? Actually, I will just explain with one small example here. Suppose if I'm having one continuum, this is second one. Okay. So initially, just assume like this is one continuum or a 3D object or something like that, right? So initially, if I want to make any equation based on this one and second continuum, initially we know like all the components, say if we consider one pen or any water bottle or something, it will be consisting of small tiny particles to form a object, right? So similarly, if I'm having one continuum here, that is we can name it as one, and the continuum 2 we can name it as it is dimensional wise it is similar only. So here, if I want to make any equation based on this first one, I'm considering only this much portion here, right? So initially we can say like there are number of points will be there, right? Number of points will be there. Here also number of points will be there, right? But I'm not considering this second continuum now. I'm just focusing on the first one only. So if I want to make any equation based on the first continuum, what are the parameters that I required? Means I need to get the number of points here that I need to get, then the degrees of freedom also I need to get. So if I know these two parameters, I can make any equation based on this continuum. But I don't know number of points inside the inside my interested area. So we cannot make any equation based on this section, right? Then I mean, what is the di of degrees of freedom? We can say. So degrees of freedom is nothing but I mean it is number of, or we can say like minimum number of parameters to define the position of an entity, right? So basically, if you consider any object, it will be having 6 DOF, right? Means 3 rotational and 3 translational motions will be having, right? So considering this continuum, I mean, the first example, I am unable to create an equation, right? So here in second, I am just doing some methods to make one equation through some process. That process is termed as discretization. Okay, so I'm just discretizing the interested area by some method. Okay, I'm just discretizing this. I'm just dividing this into different segments. Okay, so I'm having 1, 2, 3, 4, 5, 6. 6 points here. Okay, 6 points I'm having. And what is the DOF? It is 6. So 6 into 6 is equal to 36, which means I am able to make an equation if I discretize the continuum. So exactly what we have done here is like we have divided the continuum into different segments, and we are making the degrees of freedom. I mean, we are restricting the degrees of freedom. Okay, from finite to infinite to finite. That's how the name has, as the name indicates, finite element analysis, finite element. Right? Again, I will be just giving you a few more examples. Just a second. So the process is called as discretization. Discretization. And the points are termed as nodes. Okay. And the nodes constitutes to form elements. So here we are having tria elements and chord elements, right? So this is a quad element. So predominantly, I mean, there are several elements in the meshing process, actually, in the analysis, actually, but as of now, we are just looking in the tria and quad elements only. Okay. So these points are termed as nodes, and the nodes constitutes to form the elements. Okay, this is one element, this is second element, this is third, this is fourth, likewise. So there would be tria elements and chord elements. Okay. Okay, then I will just okay. So the basic finite element analysis equation, we can say like F is equal to K into delta. F is like the force vector. K is stiffness matrix. This is displacement matrix. Right? So if I am just showing one object or something, right? I'm just dividing this into segments. Say I'm just meshing this one with some global element size or 5 or something. Just assume like I'm just meshing this one. Say I'm just giving here 500 megapascal, and here I'm just giving say 100 megapascal load. Okay, so I'm giving this will be like a compressive force, right? I'm giving compressive force here and here. Suppose if I want to know what is the stress or the deformation at unknown areas, I can find it out by using the finite element analysis. I know the forces, I know the constraints, right? But if I want to know the force or the stress or the deformation, whatever, in the unknown areas, in the software, in the background, that software is having some algorithm to get the result at unknown areas by the method of interpolation. Right? So that's how the software will work. So the basic theme is to calculate the equation for a limited and interpolate for the entire domain. That is the thing which happens internally inside the software. They're having some algorithm for the same, right? So these are the things that I just want to revise or brush up regarding the FEA. I mean, in the later classes, we'll be dealing with more theories and some brush up sessions. So at this time, I think this is enough. So next, we will jump into the Hypermesh software.